Renewable hydrocarbon fuel, an overview of the biofuel. How are the biological sources grown and cultivated? Corn stover is leftover stalk, leaves, and husks after corn is harvested. It's mass produced in the US. Sugarcane, grown in warm tropical climates, it requires irrigation, fertilizers, and regular harvesting, and the juice is extracted for ethanol, and bagasse can be processed into hydrocarbons. Bagasse is the right photo. Soybeans are grown on large-scale farms, and oil is extracted from seeds and then processed into fuel. Algae is grown in controlled systems like open raceway ponds or photobioreactors. It can grow rapidly and be harvested daily or weekly. So biomass doesn't only have to be grown. It can be used for obtained from restaurants, food processors, and slaughterhouses through like used cooking oil and animal fats, and then filtered and refined into biofuels. Bio is the fuel produced. So step one, biological feedstocks must be broken down, or biological biomass must be broken down through deconstruction. Plants and algae store energy in cell walls made of cellulose, hemicellulose, and lignin, and it can be broken apart from either high or low temperature deconstruction. So high temperature deconstruction is where extreme heat and pressure break down biomass into a liquid or gas through one of three methods. Pyrolysis, which is when biomass is heated rapidly at a high temperature in an oxygen-free environment, which produces vapors cooled and condensed into liquid biocrude oil. Gasification, where biomass is exposed to higher temperature and has some oxygen, which produces synthesis gas or synth gas made of mostly carbon monoxide and hydrogen. Hydrothermal liquefaction, which is the most ideal method for algae, and water is used in moderate temperature and high pressure, and it turns into liquid biocrude oil. So these are the three processes. This is the first process, second process, and third process. So low temperature deconstruction are when enzymes or chemicals break down feedstocks. Biomass goes through a pretreatment step that opens up the physical structure of the cell walls, and this increases sugar polymers like cellulose and hemicellulose accessibility. The polymers are then broken down into simple sugar building blocks during hydrolysis. And after breaking down the biomass into oils, synthetic gas, and sugars, they had to be refined. And this step is called upgrading and can be done with microorganisms like yeast and bacteria or chemical catalyst, as mentioned before. This is the 2.2 process. This fuel is widely available due to its implementations in refineries and the aviation industry. Carbon footprint. Renewable hydrocarbons can reduce greenhouse gas emissions significantly, depending on feedstock, biomass, and production processes. Life cycle analysis indicate potential reductions of up to 80%. So the economic impact on jobs. Jobs are created in agriculture, research, and manufacturing sectors. Trade. By using domestic biomass to create this biofuel, we are producing energy that requires us to be less dependent on imported oil. It is very expensive to produce rather than using fossil fuels, which is cheaper. And there would have to be an increase in production of biomass to keep up with the large-scale production of renewable energy. So public outreach, many airlines are using and promoting renewable hydrocarbon fuels, which is known as sustainable aviation fuels. These are some examples of airlines that are using it. This is Delta promoting their sustainable aviation. And government programs like the Department of Energy are also big promoters. So renewable hydrocarbons are a strong option for cutting emissions without us needing to change engines or fuel systems, but they're very expensive. I recommend to research and invest in better technologies that will make production cheaper and more efficient, implement policies to support companies like tax breaks and subsidies. A lot of people are ignorant of renewable energy and would rather not support it since it's different. So spreading awareness could definitely help. If funding wasn't an issue, I would build large biorefineries near farms and large waste sources to decrease the time, money, and energy it would take for traveling. Increase research funding to create genetically engineered biomass so that produces efficiently. Create loop systems that fuel each other so the waste of one system energizes the other. And cooperate with nations across the world to create a global grid. These are references.